Okay.
Got it.
Yeah.
Hi judges, I'm Will McGank and I'm part of the 1B Waunakee Transportation Timeline Group, and I'm going to be introducing the team. This is Jackson Reichel, Sam Jezik, Sarah Sawinski, Tarek Lemansky, Matthew Lindley, Matthew Carls, Jack Samuelson, and Tyler Stelmacher. And we have one of our other group members, which is all virtual, and who's Carter Spirito. Jackson, go ahead.
I will introduce the machine. Transportation is involved with our lives every day. From driving to and from school, transporting goods all over the world, and exploring new extraterrestrial areas of space. We are always looking for ways to advance our technologies.
So our machine theme resembles a timeline of transportation. To begin with, we start with the wheel, then boats and ships, then trains, automobiles, race cars, and more recently, rocket ships, shuttles, and rovers.
So our machine starts by pulling the nail, and then that releases two masses that press down on the first hydraulic. Then the second one knocks a wheel down the ramp into the pulley system. The pulley then lifts the car and then pulls the first domino down, which the last domino puts weight on a lever. The marbles on the end of the lever are released into the tubing, which add weight to this pulley into the bucket. The bucket pulls the boat down and then knocks the dominoes over, setting off the mousetrap. The mousetrap pulls a gate when it's set off, and a golf ball is released to start the train. Then the train knocks a lever, knocking a wooden train car down the wooden ramp.
As the train car goes down the wooden ramp, it hits dominoes on this side, which sets off a mousetrap, which leads to our chemical reaction, which involves baking soda and vinegar to inflate this balloon, which will eventually hit the golf ball. The golf ball rolls down here into this bucket, which launches this car into another mousetrap, which leads to our spaceship over here, which gets pulled up, knocks a marble down the door funnel, which leads to another mousetrap that knocks a golf ball into this cup, which finally leads to knocking a final baseball into our button to set off our final step, which is setting off a light.
Okay, so with the engineering process, first we needed to ask ourselves what our problem was, and our problem we had to solve was what we wanted our steps and final tasks to be. So next we had to imagine what we wanted, and we wanted our machine to resemble a timeline of the different types of transportation. So then we started to plan, and we planned our initial thoughts on a Google Doc. This was very effective because we could keep our ideas organized and clean, especially with our virtual students. And then we started to create our projects. We all individually built our steps and then decided to connect them at the end. And then we had to improve. When connecting our steps, it didn't go smoothly and we had obstacles along the way. But that didn't stop us from finding a solution. We would modify our existing steps, add a new component, or remove a risky step in order to reach our goals. So one thing that we noticed throughout our machine was there was a lot of steps that included energy transfer. Specifically, you notice a lot of steps with things like mousetraps and then ramps. So then when the mousetrap was set, the objects were placed on a ramp, and then the energy from the spring contains a lot of potential energy ready to snap back, and then that will set off. And then it will convert that potential energy into kinetic energy, which can be used to trigger those following steps.
With our machine, we had a couple steps that gave us a little bit of struggle. First and foremost, this step over here with the cup and the boat on the pulley system, we figured out first, like right away, that this cup was often way too heavy for this boat and it would trigger the step prematurely, which is not what we wanted. So we had to figure out the correct weight ratio of having weight in the boat versus the weight that fell in the cup that would be enough to set it off every single time, but would keep it in place until the time was come. And the second step, the second struggle on this step was that when the chemical reaction went off, the balloon would often be crooked or sideways and it wouldn't be perfect enough to hit this golf ball to the next step. So we had to kind of re-engineer how we're going to have this string go from this mousetrap to the clip holding the balloon, and we had to use a couple eye hooks to redirect it. And we learned with these struggles that the first solution is not always the correct one, and that we had to think outside the box in order to solve our solution.
Overall, all of our group members contributed to this project because we were all responsible for certain steps, and in the end, our group was able to successfully turn on the light and complete the task. So thank you, and I hope you enjoy our machine.
Good job, group.